and 5 shirts. That's called bill of quantity. When you're going to quantify the material, how much quantity do you require? So this is just a basic difference between BOM and BOQ. Okay. So when you talk about module BOQ, we what we require to assemble a module. Okay. So first one is glass, which is on the upper layer of, which is the topmost layer of the module. Inside we have EVA sheet, which is going to lock your PV cell within it, is a laminating sheet. Then on the back side, we have a back sheet which is made by the PET to provide the long-term protection against moisture content and electric insulation. Cells are there, which is a solar PV cell, which we studied yesterday, how it manufactured. The solar PV cells are there, which is connected together with the help of bus bar. And the output of these cell going to be out through the junction box via MC4 connector and cable. So that's just a quick overview of your module. And you can see here that we have aluminium frame, we have hard temper glass, we have EVA sheet. This is upper EVA sheet, lower EVA sheet. Between that, the cell is going to be locked so that it can to be get laminate here. Okay. On the back side, we have a back sheet, as well as we have junction box on the back side with along with cable connectors and all. Now when talk about front glass. Front glass usually 3.2 mm thick piece of solar glass. When it says solar glass, it has a rough surface, and this is required because upper surface is smooth, inner surface supposed to be, little rough, so that this EVA sheet going to stick with it inside. Okay, the EVA sheet will be stick with it. Okay, that's why we require little tough glass, this roughened surface glass. EVA needs to adhere to the glass. Completely smooth glass would not adhere well and would lead to delamination. And that's the major fundament of your front glass. And when you talk about high solar radiance transmittance, let me show you, just a sec, let me see. Just let me show you one more thing in this. Let me open any one of it. Detail losses, IM loss. Okay, so here you can see how the glass is going to play the role in the generation. You can see here that we have air as a rarer media, and then we have glass as a denser medium. Okay, and then we have EVA. This sun rays has to travel from air to glass, glass to EVA. Okay, to reach to your solar PV cell for the generation. And you can see that the sun
Sorry,
radiation.
we are not able to see the.
Wait. Give me a sec. Just a minute. I think I should stop. I should supposed to share entire screen. Entire screen. Can you see now? The sun rays, air,
Yes,
glass,
Yes,
yes.
EV. Can you see this picture now?
yes.
Okay. In this picture, you can see that we have sun rays coming from sun. It is going to travel between glass to air to glass, glass to EVA. So it has to travel within three different mediums, and all these three different medium has a different refractive index. And resultant due to the difference in the refractive index, it's going to reflect back to the atmosphere and refract within the medium. Okay, and you can see it's keep strike restrike on the multiple point, and resultant you are going to, let's if you receive 100 watt per square meter irradiance from the sun here, but you only going to receive till module about 70 watt or 75 watt, means 20 to 25% of radiation will be going back to atmosphere, reflect back to atmosphere, and for some component will be there which is going to strike restrike again and again. Resultant, the temperature rise within the PV module. Okay, the temperature rise of your PV cell due to this multiple striking, restriking. Okay, that's how the sun, this glass going to act in your PV plant generation and your on your PV module. And thereafter you can see this glass should be made with the by using the low iron oxide to ensure that the high solar radiance should be there. The maximum radiation will be transferred to the cell without any interruption. Okay, and that's how the glass going to be manufactured with the help of iron oxides. Now when we talk about strength, solar panel are made of temper glass. Okay, sometimes these glass called toughened glass as well. Okay, and there's one more thing I would like to ask, anyone can answer. Uh, we used to have, we going to apply the temper glass on our phone on the screen. Who used to do? Robin or Yogi? You do? You
Yep.
apply temper.
Yes, sure.
Yep.
Why we applying the temper glass on that?
Just for the
To
protection of.
prevent accidental breakage or something.
Yes, yes. So have you ever removed the temper glass manually by yourself sometime?
Yep.
It's very hard to do.
Yeah, it's very hard to do. But does it hurts anywhere? Does it going to have a cuts on your hand or anywhere? No.
No.
That's how the safety glass work, and that's the job of our solar panel glass. It's a just first of all, it's a temper glass. It's a much stronger than other type of glass. Secondly, the temper glass is considered as a safety glass. In case of brick, it will be shattered in thousand small pieces that won't be harmful to anyone, not going to say any harm to anyone. Okay, so that's why for safety purpose, for strength purpose, that's considered as the most required or most recommended glass. When you talk about durability, solar glass is going to act as a front sheet of your PV module, which is going to give you the long-term protection against the element or long-term protection against atmospheric disturbance. Now, what is atmospheric disturbance? Dust, soil particles, moisture content, rain, or a heavy hailstorm is going to provide you long-term durability. When you talk about disadvantage, it has only disadvantage that it is going to carry the 70% of module weight. If you have a module of 25 kilogram or 49 pounds, out of that 70% weight is contributed by this temper glasses only. Okay, and second, after that, when you talk about glass, we know the glass is there, so it must have some strength which is going to be bear the things, and after that they're going to be breakdown. Okay, in order to ensure the breaking should not be happen very quick or easily, so we are going to use the 45 thick aluminum frame on the outer edges of the module to provide the long-term protection test against mechanical strength where we're going to apply 2400 pascal mechanical load and 5400 pascal of snow load to ensure that it's not going to break easily, because most of time when you transport the PV panel, the glass is the main component going to break during the transportation, during the transit. Okay, so that's how it happen in the PV module. And now second thing is come here next is anti-reflection coating. As you seen in this picture that there is some radiation is reflect back to atmosphere. In order to protect that, the reflection content should be utilized to generate. We are going to apply one anti-reflection coating on the top of the glass so that it will absorb more radiation and reduce the reflection content. Resultant, your production will increase by 2.5%, but actually on the ground the production or generation will increase about 1.5 to 2% maximum. Okay, so anti-reflection coating is another part which is nowadays a standard practice. You may see in the most of module has anti-reflection coating on the top of it. A part of that, some manufacturer also offer additional. Okay, like they will charge you additionally and they will provide you anti-reflection coating on the surface of your PV module. So this is all about glass. If anyone has any question, you can ask me. Otherwise, we'll move in this next this content. Any
Let's
question?
proceed.
All right.
No.
So now we talk about EVA sheet. But in EVA sheet, it's called ethivinyl acetate. EVA stands as ethivinyl acetate. But before going into it, I would like to ask a question to anyone going to answer me. You may have your educational credential, your schools, your college, your mark sheets are there, your degree, your certificates are there. Have you laminate them?
Yes.
Why you do laminate?
Because the paper degrades over time.
Yes,
Either
your
it's
paper
or it's
degrades over
malhandled.
the time. It's going to react with the atmospheric available content, because in our atmosphere, in our air, we have many types of gases available: nitrogen, oxygen, okay, and other moisture content are there, which is going to react with the paper over the period of time and going to degrade. The same happen with the PV module or PV cell. We are going to use the EVA sheet as a lamination of the PV cell. But lamination is a layman term. In a technical term, that process called encapsulation, because here our cell is not going to stick with the sheet. Our module is going cell is going to lock between the sheets. You can see upper layer of the sheet, lower layer of the sheet. This sheet is going to stick on the corners by themselves. It's not going to stick with the cell. And in order to ensure this encapsulation process not going to trap any gaseous content, this process usually happen at high temperature of 150 degrees Celsius, so that at high temperature all the gas is going to exit out from the atmosphere and you getting the pure vacuum there. So this process usually happen at high temperature under high vacuum, so you will not trapping any gas content, and resultant it happens. Okay, so that's how it goes. And thereafter, once the EVA sheet has been laminated, the ethyl vinyl acetate sheet play an important role in preventing humidity and dirt penetration in solar panels. Like as you told very correctly, that we are using the lamination to protect the document, which is going to degrade over the time of period, because it's going to react it has a moisture content in the atmosphere, we have gases content, we have soil, dust, particle, lot of things are there which is going to react with our solar cell. So we are protecting the cell from this atmospheric content. Okay, that's why we require to laminate the cells by using the EVA sheets. And in the EVA sheet, the cells are floating between the glass and a back sheet, helping to soften shock and vibration and therefore protecting the solar cell and its circuit. Okay, that's how. And when talk about durability, when you do lamination of a document, your lamination getting little hard. Okay, it's getting hard. So same happen here. The EVA sheet is going to provide the long-term durability to your PV cell, because PV cell is one of the most delicate in the nature. It's fragile, it can easily break down. So in that case, we should be careful about it. So this EVA sheet is going to provide the long-term protection and provide the excellent durability. And when you talk about bonding, under the right circumstance, EVA film have an excellent adhesive bonding to the glass. Also, EVA very well stick to the back sheet. It means that this EVA sheet will stick to glass on the upper side, and lower EVA sheet will stick to the back sheet, and it will going to connect with each other and going to paste with each other on the corners and lock the PV cell within it. Okay, that's how it goes. And thereafter we have optical thing. When you talk about optical thing, you can see in this picture very clearly that the refractive index from air to glass is changing. So this radiation is deflected from their original path, and from glass to EVA it will coming back on their own, it's regain its own path, the original path, which means that EVA has equivalent optical or refractive index arrangement as per air. Okay, so EVA is going to offer us the most best optical arrangement. It provide excellent transparency. This means that is optical transmission is acceptable and does not block too much of sunshine trying to reach solar cell. Nowadays, this concept will come in next. Okay, so this is called which is called EVA. Now when talk about back sheet you might be usually seen white in color. It's just like a plastic material, but no, it's a material called PET, polyethylene terephthalate, which is going to provide the long-term protection from the backside, moisture protection, durability, electrical insulation, and the white color help to reduce down the temperature from the backside, which help to generate more power from the PV panel. And these back sheets nowadays, even you might see the bifacial panels are there. Bifacial solar panel. In the bifacial solar panel, you might see the back sheet is now more available. It's a, or either a transparent back sheet. You can see. Let me show you. This is. Wait. Yes. You can see you can easily see the cell from front and back side, which means that it has a transparent backsheet on the back side. Front side we have a glass. And how it going to work? You can see usually a conventional panel work from the front side only, and when we have opaque backsheet, the radiation which is going to reflect from the ground due to its albedo, it's going to reflect back and not getting any benefit into it. Once you replace this opaque backsheet with transparent backsheet, it will generate from both sides and resultant called as a bifacial panel, which means it has a two phase of generation. Okay, and the bifacial panel is more likely to be used in the desert condition, or where we have good albedo. Now, what is albedo? Albedo is the reflectance property of the ground or a surface where you installing the PV panel. Let us assume from sun you have received 100 watt per square meter irradiance, and the same radiation is falling on the ground. Okay, 100 watt coming directly from sun and 100 watt falling on the ground. But now albedo going to decide how much percent radiation will going to reflect from ground to back. Let's say out of 100 only 20 watt is only reflect back to the surface, which means the albedo is about 20%. Albedo is 20% there, which is reflecting back the radiation back to the atmosphere, and that will be used to generate from the other side of the PV panel, which make it more beneficial to generate more power. Any question till here you can ask me regarding backsheet. However, there's a one table are there. You can easily see backsheet what's going to provide you moisture protection, provide you UV protection, safety, color. These all are basic fundamentals here. But usually nowadays you are not getting this opaque backsheet. If your company paying you more and they are going for a project, they can go for bifacial. You will get gain in energy. You will get more power generation, and that's all due to the bifacial panel only. Okay. Any question till here, or we'll move ahead?
Let's move ahead.
Okay. Now we talk about bus bar. Bus bar in solar PV panel. Can you talk about bus bar in solar PV? What would happen here? Wait. Bus bar in solar PV panel. When you say bus bar in solar PV panel, so in terms of bus bar, before going into it, I would say one more thing. Let's say, Yogi, you are from India and used to travel UK. How many flights you have daily from India to from Delhi to UK or Manchester, wherever you go? How many flights you have?
Mm, I'm not sure, but maybe couple.
Let's say
10.
2 flights. Let's say okay, 10 flights. That's fine. 10. Let's say 10 flights. Are you getting seats easily when you, let's say you're supposed to need a seat tomorrow? Are you getting seat tomorrow?
No.
No, because we have a limited number of flights. We have
Yep.
unlimited passenger traveling every day. They have pre-planned arrangements. Okay, so
Yep.
you're not get seat. What happen usually, the airline is using their aircraft to run around the clock, and they have a staff who should be available whenever they required, and they keep running. Okay, which means the airline may not spending much time for aircraft maintenance. Okay, so they have number of fleets are limited, and they are keep running round the clock to earn more profit. and the staff like a pilot and a crew member, they are keep running, and they supposed to, they are already pressurized a lot not to take leave. Okay, because it should be otherwise it's going to impact their business. In that case, the staff, first of all, aircraft not getting proper maintenance, it's going to degrade quickly, the life going to reduce. Second, the staff, the crew member which is going to operate the flight, they already working in stress not to take leave, they don't get proper rest and all. Okay. Third one, being a passenger, you're not getting a flight seat confirmed. Okay, so you all are suffering. Okay, but out of sudden, let's say Rishi Sonak become the PM of PM or president of UK, and he start, let's have 100 flights from India every day. Now what happened? Every flight may not get full. First,
Yeah.
second, everyone easily gets seat whenever they want. Let's say if you want seat in next 2 hour flight, you will easily get. Thirdly, the rush is less, so the flight maintenance will be there proper, the life will be gained. And the other one is the staff who's going to operate, like a staff or a crew member, they will get proper leaves, they will get proper rest because they don't have much stress on it. Okay, that's how it goes. But same happened with our bus bar as well. Now bus bar is something which is going to use to connect your PV cells in series. You can see there are three cells are connected in series. These are the white are a bus bar. White are the bus bar. You can see this is it's a silver strips, and it's connecting the cell in series. And let me show you more examples of this. Give me a sec. Mm, Bus bar string of solar PV. There it is. You can see there are the cells are connected in series. Okay, these are the PV cells, not PV module. So it's just like these all cells are connected in series, and we know basic fundament in series, they are contributing for voltage. What? They're contributing for voltage. Okay, so these cells are connected in series, and that's how bus bar is used. Now in the bus bar, when we talk about, there's a bus bar, they are saying in bus bar we have four fundaments: higher bus bar, higher efficiency; higher bus bar, higher lifespan; higher bus bar, lower degradation; higher bus bar, lower residual stress. Okay, now what is residual stress? Which means that when your panel is operating at its peak, generating more electron, so bus bars are capable to adapt them. They're not in getting stress. Okay, they will easily adapt the rest of electrons available from the generation side. Okay, that's how bus bar works. So whenever you say, whenever someone offer you, let's say a panel A with 5 bus bar and panel B with 3 bus bar, so you should always go for higher bus bar, because higher bus bar offer you higher efficiency, higher power output, less degradation, less residual stress, and that's how it is. But apart of that, the manufacturing up and down thing I'll mention here. So manufacturing up and down thing is something like that. Like when I start my career, the 2 bus bar and 3 bus bar panels are there, but now in the market 12 bus bars are there. Okay, so if at that time the companies are, let's say 10 companies are there in the race, let's say 10 year back, but down the line today, they all shut down. Only 3 companies still continuing. Why? Because let's say you should be with the technology upgrade. Okay, whenever something new is coming in the market, you should follow that, and you should keep change your manufacturing strategies and follow the technology. Otherwise, you maybe end up with shutdown. And that's how it is, because this PV module manufacturing usually works with the robotics manufacturing lines are there. It need a huge cost investment. If anything goes change, you have to change the complete line. You're not able to change just one or two machinery and that's work. No, if some technology upgrades are there, you should be keep follow with it. If you not follow that, you may end up with the shutdown or you may lose the race. Okay, so that's how it is there. So be sure whenever you go for higher bus bar and be with the trends, okay, in terms of manufacturing. A part of that, the summary says very clear, when someone offer you higher bus bar over the less bus bar, you should go for higher bus bar for more power output, more power generation, less degradation, less residual stress. Okay, that's just a summary for the bus bar. And now it comes on junction box. Junction box is something which is a final, where you're taking the final output from your PV panel. And there you can see junction box is marked with the dotted lines. And here you have few diodes. Okay, and we know the basic theory of diode, it act in the reverse polarity. Okay, as you can see, the current is flowing from left to right. It means electron movement is opposite. Electron movement is opposite. That's why it's moving toward left to right. And this is just a standard module, is a highly operated module. It works like this. But what happen if in case, let's say, any cell got here shaded in this let's say string number 1, string 2, string 3, string 4, string 5, string 6. Any cell got shaded here, let's say cell number 5, string number 6 got shaded due to bird spot, due to some I would say some leaf is fall, or due to some issue. Anyways, this cell got shaded here. And we knew it very well, one more thing, if we install 100 bulbs in a series, if bulb number 49 going to be blow down or destroyed or damaged, so 49 onwards all the bulb going to be not going to glow, it's going to be all fuse, because it's all connected in series. So if it means here one cell got shaded, the power got disrupted here, it won't allow the final output. In that case, this string going to offer the higher resistance, and electron is just a person who's always looking for a low resistance path. And this bypass diode is going to activate in the reverse polarity and going to offer a bypass path to flow the power which is generated by rest of modules, which means that at this time your module is not working at 100%, because this 30% module is out of service already. 30% of module is already out of service. So 70% module are contributing, and contributing the power by using the bypass path which is offered by the bypass diode. Okay, that's how the junction box work. Now in terms of junction box, let me show you one more thing. Module, the junction box has two type of arrangement. Okay, we have a conventional module like with single junction box on the back on the top. Okay, that's a single junction box default. Okay, where if any leaf fall on this string, the complete string going to be shut down. This complete string going to be shut down. Out of 3, 1 is out. Okay, so the module is operating at its 70% of its rated capacity. Out of 60 module, 20 module out, only 40 cells are working. Okay, but nowadays the technology got changed. We are using half cell module. Now what is half cell? We change the position of this junction box from upper to move it in middle. Now we divide the module in two parts. We half the cell upper, half cell on upper, half cell on lower side. Okay, and we reduce the size of cell as well. So what happened here? If the same leaf fall on the panel here, but instead of complete string like this, it's not going to shut down. It's going to shut down. It's just 10 to 15% of the module on the upper side. Rest complete module are working independently without any disruption. And that's how the technology got evolved nowadays. And we are using half cell module most of time. In that half cell module, you can see how the power flows. This is just a power flow of within the half cell module, upper part and lower part. If lower part got shaded, upper part is independently working, and upper part got shaded, lower part, they both are independently working. Okay, and connected in parallel formation, where they are contributing their power totally on the left to right flow. Okay, that's how our total PV cells are working, and how the junction box are changed. And junction box has diode. Let me show you those diodes as well. You can see The diode are there. These are the diode, small diodes. This is the diodes here, and they have a tapping arrangement. This is metal strips here. Metal strip 1, point 2, point 3, point 4. Okay. This is output terminals. This is junction box. And the output terminal like MC4 cable connector. MC4 is multi-contact 4. Okay. It has a male, female connectors. Let's say it's a positive, it's negative, or we can say male or female, whatever you call it in your terminology that you can use. But MC4 connector, we usually call this. It has a diode. We usually have 3 diode model in our PV modules, where we have one module diode, 2 diode, diode 3. So these 3 diodes are there, and this highly used in the market at this moment. So this is what about